Did you ever stop to wonder how vast the universe truly is? It's a question that has sparked curiosity and wonder in humanity for centuries. In our quest to understand the universe, we often use familiar comparisons to grasp its enormity. Imagine, if you will, a grain of sand. It's tiny, right? Now, imagine a beach filled with these grains of sand, stretching as far as the eye can see. The number of grains of sand on that beach is staggering, yet it pales in comparison to the number of stars in the universe. The universe is so vast that it's measured in light years, which is the distance that light travels in a single year, about 6 trillion miles. If you were to lay out football fields end to end, it would take over 5.5 million of them to span just 1 light year. That's a lot of football fields. And yet, the observable universe is estimated to span a mind-boggling 93 billion light years. But what are all those stars part of? They're part of galaxies, swirling masses of stars, gas, dust, and dark matter bound together by gravity. Just like the stars, galaxies are incomprehensibly numerous. Current estimates suggest there could be as many as 2 trillion galaxies in the observable universe, each filled with millions, billions, or even trillions of stars. So, the next time you're out on a clear night, take a moment to look up at the stars. Each point of light you see is a beacon from a distant sun. Some of those lights might even be from galaxies far beyond our own. So, next time you look up at the night sky, remember that each star could be a sun to an entirely different galaxy. Have you ever thought about how it all began? Our universe, with its billions of galaxies, stars, and planets, started from a singular point some 13 billion years ago. This idea, known as the Big Bang Theory, is the leading explanation among scientists for the birth of everything we see around us, and even the things we can't. Now let's imagine a balloon. When it's not inflated, all its points are close together, right? Well, think of that as the universe at the time of the Big Bang. Everything, all matter, all energy was condensed into an extremely hot and dense state. Then, in less than a fraction of a second, it began to expand rapidly. Just like a balloon being inflated, the universe stretched and grew. This isn't just an expansion into space, but an expansion of space itself. But how do we know this happened? What evidence do we have? Enter the cosmic background radiation, also known as the echo of the Big Bang. This radiation is a relic from the early universe, a snapshot of the cosmos when it was just a baby, only 380,000 years old. When scientists first discovered this cosmic background radiation, they found it had a temperature of about 2.7 degrees above absolute zero, nearly the coldest temperature possible. This was exactly what they expected to find if the Big Bang Theory was correct. This radiation is, in essence, the afterglow of the Big Bang, the remnants of the intense heat that filled the universe shortly after it was born. Every direction we look in the sky, we can see this radiation. It surrounds us, penetrates us, fills the universe. And it tells us a story of a universe born from a singularity, a universe that has been expanding and cooling ever since. Like the echo of a great explosion, the cosmic background radiation tells us the story of the universe's birth. What if I told you that most of the universe is something we can't see or touch? Just like the wind, we can't see it, but we can feel it and see its effects. That's the best way to understand dark matter and dark energy, two of the most elusive and enigmatic components of our universe. Imagine you're standing in a field, watching trees sway. You can't see the wind, but you know it's there because of the rustling leaves and bending branches. Similarly, we can't see dark matter, but we can observe its gravitational pull on galaxies. It's like an invisible cosmic glue holding galaxies together, and without it, they would simply fly apart. Now let's talk about dark energy. It's even more mysterious than dark matter. If dark matter's gravitational pull is trying to hold everything together, dark energy is doing the exact opposite. It's like a hidden force that's pushing galaxies apart, causing the universe to expand at an accelerating rate. Dark matter and dark energy together make up about 95% of the universe. yet we know so little about them. That's like knowing only 5% of a book and trying to understand the whole story. Scientists are using the most advanced telescopes and detectors, trying to capture a glimpse of these unseen forces to read the rest of the cosmic story. There are many theories, from the possibility of unseen dimensions to the existence of new types of particles. Each one offers a tantalizing clue in this cosmic detective story. But as of now, these remain theories, waiting for that elusive evidence to transform them into facts. So the universe is not just what we see, but also what we can't see, a mystery waiting to be unraveled. The dark universe, full of dark matter and dark energy, is a testament to the vast mysteries that lie beyond our current understanding, waiting in the shadows for us to shine a light on them. Ever wondered about the future of the universe? Just as we contemplate our personal futures, the destiny of the universe itself is a subject of intense scrutiny and speculation. The cosmos, vast and mysterious, has an uncertain future, with various theories proposing different outcomes. Let's delve into a couple of these theories. The first one is the Big Freeze. Imagine the universe as a stretching rubber band. The Big Freeze suggests that this cosmic rubber band will keep stretching, expanding forever until it reaches a state of maximum entropy or disorder. Stars will burn out, galaxies will drift apart, and eventually everything will cool down to a near absolute zero temperature. The universe will become a dark, cold, and lifeless place. Now, let's consider another theory, the Big Crunch. In this scenario, the stretching rubber band decides to snap back. The universe, after eons of expansion, will reverse its course and start contracting. Galaxies would rush back together, temperatures would rise, and everything would culminate in a fiery singularity, a point of infinite density. It's like rewinding the Big Bang, leading to a possible rebirth of the universe in a cyclic process known as the Big Bounce. These are just two of the many theories scientists have come up with to predict the universe's fate. Each theory is based on our current understanding of cosmology and supported by complex mathematical models. However, it's important to remember that these are just theories, and new discoveries could always change our perspective. Just as our lives are filled with unexpected twists and turns, the universe too has its share of mysteries. As we continue to explore the cosmos, we might stumble upon new revelations that could rewrite these theories, painting a different picture of our universe's future. The universe's future, much like our own, remains a mystery yet to be discovered. So, where do we fit in this vast cosmic arena? Consider for a moment the staggering size of our universe. Earth, our home, is but a tiny blue dot floating in an incomprehensible vastness. Our planet, our solar system, even our galaxy are mere specks in the grand tapestry of existence. It's breathtaking, isn't it, to realize that in the grand scheme of things we are so small, so seemingly insignificant. But don't let this immense scale belittle you. For despite our cosmic insignificance, Earth holds a unique and profound significance for us. It's our only refuge, our only home in the vast cosmic wilderness. It's here where we've developed civilizations, discovered the laws of physics, and dared to dream of reaching the stars. So yes, in the grand cosmic arena, we might be minuscule, but we are not insignificant. We are just a tiny part of a grand cosmic dance. But remember, this dance is incomplete without us.